Welcome back to Deep Thoughts, ladies and gentlemen. Today we're going to cover a subject that has been requested, and it's been on my list for quite a while. And boys, this is going to be a doozy of explanations. It's going to take me a little while. I'm just going to tell you how this is going to go. Hopefully this makes it. Just got a brand new box of my favorite cigar for the show, which is the Herrera Steli Toro. I smoked all my La Plumas. Loved every single one of those sticks as well. Thank you to the La Pluma folks for sending that box over. Last time I did one of these on the first box, it had a big tunnel down it, so hopefully it doesn't happen here. Quantum computing. I finally took the deep dive in quantum computing, and this is going to be a multi-dimensional episode because what we're going to do is we're going to I'm going to attempt to explain the quantum computing as accurately as I can. And then we're going to talk about the amazing amount of hype coming around this technology. And then probably reflect on how it is definitely exciting. It'll be interesting to see if they can make this work, and it's sort of a logical progression in one way or the other to refine the way that we store data and manipulate data. But they're currently in 2019, we're a few inventions away from making this really a super plausible solution, such that it actually achieves what we think it's going to achieve, which is a much faster world, much faster computing world. So what is a quantum computer? I hope to God you guys have some computer background. And this isn't aimed at anyone who is completely informed about all this stuff, because it'll be a little bit boring. The one thing I'm going to do is mix in some of my ethereal research into this, such that we can acknowledge some of what's really going on with some of this. It's not terribly important because we can work with the higher end concepts of atomic energy and matter in general, as it is created by ethereal winds. There's still some fascination about some basic experiments. I don't really think the experts have any fascination about how, the slit test of light creates a reverberation on its receiving sensor and that kind of stuff. And I'll try to put some images in here to help explain some of this stuff. So how does a traditional computer work deep down inside of its guts? I'm going to try to make this easy for everyone to understand, even if you've never done anything in computers, because some of the things I'm going to say are things that you've heard. And then what I'm not going to do is persecute your mind with over explaining various examples of how things work. But we're going to have to get into some of this in order to explain things. Your normal computer, it works by storing zeros and ones. And everything is broke down from zeros and ones. And then we have hardware that metabolizes up zeros and ones. I mean, there's only 2 digits to be able to do normal decimal base 10 mathematics, which is what you and I use when we go to the grocery store. Why do they call it base 10? Base 10 because there are 10 unique digits that we use to represent all numbers. Now, some societies were living in a base 9 for quite some time because the idea of a null or a zero or a not, depending on where you are in the world, was not conceived of by a lot of societies, because what they did was they said, well, if there is nothing, if that's what we're talking about, then it wasn't a numerical digit that they wrote down. They simply would stop and disengage from mathematics and go, well, if you've taken my last apple, then I have none. And that means something different than 0. So eventually Western societies, and I think Western societies were really the first to pioneer the zero. We got 0, 1 through 9. That's 10 digits, and that's why it's base 10. I give you one little complex example, which won't take much for you to understand, but you have probably heard in your lifetime a hexadecimal system, which is a base 16 system. All that means is we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we say A, B, C, D, E, F. We had 6 alpha, alpha characters, right? Alphabetical characters on the end. And then once you've spent the last character, you go back to 2. Right? So 1 goes all the way up and then 2. But 2 would equal 17 and it wouldn't equal 2. That's all you need to know. There's all kinds of ways to count in different sets of numbers. If somebody said, look, I'm only going to give you 0 through 3, then you're in a base 4 system. I give you that example because 1s and 0s have been arranged in a way inside of a computer's brain to represent what we think of as in a base 10 system. For example, 0 is 0, 1 is 1, but 2 is actually 10, 1, 0. Because if a 1 comes down the chute and there's already a 1 there, that flips to a 0, and then you just put the one that you're trying to put in place over to the left, and then the next number 3, the 1 comes down, it's a 0, and so it can take its place. Instead of flipping the number, it does flip it, but it's 1, 1. That's 3. This is the stuff I learned when I was 11, and this is how we drew artwork back in the day for old computers. If it was a 0, there was no pixel there. If it was a 1, then you put a pixel there, and then you could give it a color. The whole strip, it was a strip of 4 binary numbers, and then if it was a 1, you got a pixel there. If it's a 0, you didn't get a pixel. So imagine taking every combination of 4 on-offs and then using that to build a picture. And you could only give stacks of 4 at a time a different color. So if you wanted to have one pixel have a different color than in a particular strip, you'd have to stack 2 strips on top of each other. And it's going to say, there's 1 pixel here, and it's red. Anything underneath is a blue. Anything underneath that, maybe it's green. Whatever you're trying to do. Okay, hopefully that wasn't terribly confusing. I can see a major headache for animating this thing. So here's how I think quantum computing came around. And this will help explain why quantum computing is so nebulous and difficult to understand how it's going to be used. And you need to understand that a giant portion of quantum computing, I would say the lion's share of all the research that has to be done to really make these things fall into every device in your life, especially to eclipse the speed of the old system, it's some years out. But someone got the idea, look, let's work with something super teeny tiny. And that way, if we can master teeny tiny methodologies of registering a 1 or a 0, then we can pack more computing into a smaller place. And we could use literally fractions of a fraction of a fraction of a fraction of electricity to actually control the device. And so you could have a supercomputer, I mean like a real one where even today it's a big warehouse somewhere, you could have that thing in what looks like a piece of pepper on your plate. If they could get quantum computing completely down to the quantum level of actually controlling it and how it works. I know I'm getting confusing here, but stick with me. So when they look at computing, they know they have to start with this 1 and 0 theory, because everything that man has ever designed for computers builds up from this binary system, this 2-digit system, zeros and ones. And so they look for things in the universe that are naturally bipolar. It's got a 1 or a 0, and in one particular state. And then they look for the science to say, okay, we found this thing, and the way it does its thing, I think we might be able to control it by this methodology, that methodology, and then if we put a bunch of these things together and we could comfortably transmit our data to it, meaning we can change them as we want them from ones and zeros, whatever it is. Could be apples, right? I mean, if apples just sat on trees and some of them were upside down and some of them right side up, you could use an apple tree to make a computer, as long as from a distance you could tell every apple which way to be, and then some other system reads the states of the apples and goes, oh yeah, totally, it's number 5, you know? So what they've done is they've isolated some types of atoms. I think phosphor, is that one of them? Silicon. They have figured out atoms that are fairly fundamental. They don't have a lot of pieces and parts to get in the way of what they're trying to do. Hydrogen is sort of, I think, a little too explosive and chaotic to be able to control. And so what they're trying to do, this is brilliant, is they're trying to take the orbital idea of an electron and control it such that it has a state that can be recognized as a 1 or a 0. Now, the true existence of an electron is bunk science, okay? It is not a little particle that flies around the outside of an atom. That's not what it really is. What it is a force field cloud around the outside of an atom. It is as I always say in my ether episodes, okay? When the ethereal particle hits the center nucleus of an atom and bounces back like a ricochet, that's your dielectric wave of energy. When ethereal particles get stuck in an orbit because they miss the center and they get pushed by their buddies, right? It's like being pushed in a crowd. They get pushed by other buddies on all sides, so it's a three-dimensional cloud of orbiting ethereal particles. That's your magnetic wave, okay? When the two collide, which is happening from all sides, okay? The orbit's a cloud and ricochets are coming off tangent to their impact. Like, say this microphone was a nucleus, comes in, bounces off in every conceivable direction constantly. That collision creates a spin. And that spin is where we start to call it an electron cloud. And it's made of what we now call, the two hitting each other is called the electromagnetic field around a particular nucleus. Now, at the same time this is occurring, because the universe is comprised of ethereal particles are always going into the nucleus as well, into the microphone, and they come out the bottom, and they actually come out of the top and go into the bottom, right? So they theorized this on paper, and they said, of course, the word quantum just makes it sound cool, right? So they theorized this on paper, and then they started attempting to control the polarity of this cloud. Which way is the cloud spinning? And they know that it has a north pole and a south pole. In a pure state, there'll be a perfect alignment for this cloud such that everything is in a spin up, is what they call it. Just think about this whole, Van Allen belt thing, and, we have compasses that point north when it comes out of the top of Earth and goes into the bottom. But if you could take the core of the Earth and rotate it, the plasma energy that's creating this thing, it's in the center, not nickel iron. Nickel iron loses all magnetism at 6,500 degrees Fahrenheit. It's all bunk, right? Everything has plasma interiors created by ethereal particles, okay? But if you could take it and rotate it, then you would have the positive, or at least the ejection point at the bottom, and it go into the top, and that's what they call a spin down. Sounds pretty good, right? The way that you actually control the spin orientation of this electron cloud is to hit it with microwaves. It's so ethereal, it's crazy, and these people don't even acknowledge it exists, right? It's really funny. Well, what's a microwave, right? It's a wave of energy with its own property. It's just like the wind that blows on the bridge back in the 30s, and the bridge starts to feel the frequency, and then it pops and blows up, and all the cars fall in the water, right? Well, you can grab with one wave that's of the perfect frequency, you can grab of a particular electron in a particular orbit around a particular atom. They have to figure out what exact frequency it does. It's pretty easy because they'll put it on an oscilloscope on the electron cloud, and they just kind of rotate through a big wave, just like turning the knob on your FM radio. They just go across, and then when they affect that wave, they're like, oh, this is it, 45, right? And once they dial into it, then they can modulate it and turn it. And then what's cool about it is they can get in between states. And this is the natural state of an electron cloud, because the electron cloud is constantly just whirling around this center nucleus because it's being collided by all kinds of ethereal particles from all sides. And so the natural state of an electron cloud is it's constantly spinning between north and south. It means it's also registering at any one point in time, every single time in the day, if it was a clock, right? If 12 o'clock was north and 6 o'clock was south, it's also spinning so quickly that any quantum moment in time, right, a little packet of time, it is everywhere over a distance of time. Now, if you could snapshot it and really get it, which the uncertainty principle prohibits us from doing this accurately, then we'd know exactly where it was at a particular time. But the next time we measure, it's going to be in a different location. Unless we exert energy on it, just like taking the cover off of a compass and you put your finger on it, you can move it to wherever you want. You're exerting energy to move the little arrow around. That's what they have to do if they want to control this thing. So what I think they found out is, let's mess with and try to probe and then control the anatomy of an atom so that we can take all this information we're processing in silicon chips and little silicon bumps that hold charges, right? Zeros and ones, right? And there's actually a null in the center, right? But basically, if you drew a line, just so you understand it, in normal electronics, if you drew a line down the center of the page and said that's zero, that's nothing, that's no charge at all, there's no electricity going towards this particular component, you can put a negative charge in there and you're going to get a square wave below the line, and that's your off state. And then you can put more energy in and put it in an upper state. And that's where you get your positive, your negative, and your neutral. Your neutral is basically the component's been turned off and whatever data is there is useless. So when they started this process, they realized immediately, well, geez, we don't have like off-the-shelf inventions to start talking to atoms and controlling exactly what state they're in. And so they had to deal with this issue, and what's sort of going on right now, if you look at TED Talks and other people trying to champion this technology, there's some scientists that are being extremely honest, and I salute them 1,000% because they're where the progress is actually occurring. I've seen a TED Talk about this technology, and it was one of the worst examples I've ever seen of explaining this, and then it just sat there and promised vaporware. Oh, it's going to help cure Alzheimer's. It's going to help this and that and this. They just pull things out that'll make you feel passionate. So anytime a bill comes by or a prop or whatever, you're excited to fund it. And you should be, but not for these generic stupid reasons, right? They can't 100% control this stuff on demand just yet. There are some quantum computers out there, and you can actually lease one, and IBM has one that's actually online, but it has at least 3% error currently, and they'll get through these phases at some point. The average computational speed of a particular transaction in a normal chip in a normal computer using the ones and zeros old technique of today was admitted by one of the more brilliant quantum physicists who's working on this technology, the new technology. He says, look, the individual task is probably faster on a traditional computer. But because of the way that we approach processing data with quantum computing is so much different, and I'll give you a great example that this girl did this video online, and she gave the best example of this. But because of the way that they process almost everything simultaneously On the quantum side, even though each one of the instructions is slightly slower to do currently, it might get faster later, it's actually not winning the individual sprint. But in the marathon of data analysis, quantum computing can eat our normal computers alive. But it's not going to be something that you would use for Photoshop or cruising the web and writing an email or that kind of stuff. You don't need quantum computing for those tasks. We already have that under wraps. Now, does that mean the innovation in those areas should cease? Absolutely not. I think that we could probably, honestly, we could tap. If Apple wasn't slowing down devices intentionally and versions of software are intentionally slowed down with updates, if we could get rid of that criminal cabal of the way the world works today, then we could probably survive off of maybe a 5 gigahertz chip for the next 50 years. That's not the case for 3D people, Photoshop people, video editing people that need to crunch a lot of numbers. They still need the old technique to run as quickly as possible. So they could probably top out at maybe 50 gig or something like that, where it's just there's never a completion bar. Anything you conceive of can be done immediately. As soon as that occurs, Pixar is doing another Nemo video and they want to calculate refraction of water looking through the camera. As soon as that's just real time without rendering and it's photoreal and it's 8K or whatever the hell they want, we're good. We don't need to innovate past that point. But let me give you a tangible example of how a quantum computer would do things differently and thus faster and better than a normal computer. Imagine you had a maze, and the maze has, let's say, 8 entry points, but 1 exit. And it all combines and connects inside the maze. So all the paths will lead you to basically any place that's inside. But what you're supposed to find out in this particular test is what is the fastest distance, the shortest distance, I should say, from a particular entrance to the 1 exit. And you can make this as complex as you want, but this is an easy way to think about it. Well, what a normal computer would do is systematically, let's say there's 8 entrances and 1 exit, and it all combines in the center. It would push into one and it'd go down every single path until it found every wrong way and then finally finds the exit. And then it measures how long did that take, how many steps did you take, how much distance did you travel, puts it in a table. And it goes to the next entrance and does the whole thing over again. Every single entrance is going to be examined one at a time, and in the end you look at your table and whatever has the shortest distance is the shortest distance. They call this the A-star algorithm in video games. It's been around forever. So anytime you play a video game where an enemy is tracking to you, it's doing the A-star algorithm and it's looking around you to find where you are and what will be the best way to get to you. And then there's other artificial intelligence that's added to that to move around obstacles and hide and do all kinds of cool intelligent things, right? But the basic thing is that a normal computer is going to test 8 entrances. It's going to take, and it can't do 2 at once. You could program it to do 2 at once, but here's the thing. A quantum computer would go into that solution, or go into that problem, I should say, to find the solution. And it, by design, because of these bits never really truly being a 1 or a 0, they can control it. But if they just allow it to be this cloud between 0 and 1, it will go into that maze and it will go at the very first operation into 8 entrances at the same exact time. And whoever wins first is immediately the best way. And then they could abort all the other searches because it's just like a game you would play in a backyard. Whoever gets to the exit first wins, period. It doesn't matter how everyone else got there. So that's sort of a physical difference between the two computers. So now if we call the bits in a normal computer bits, that's what a bit is. If you want to know what a binary number is stored in, it's called a bit. It's 1 or 0. That's it. The quantum computer has something called qubits. Qubits, right? And so The cool thing about qubits, and this is where I'm going to try to make this as simple as possible. I'm trying to think of the easiest way to say this to you guys. Imagine the way we buy cars. And when you want a car in a particular color, and a car can come in 4 colors. And if you were to try to describe the choices to a customer, it's pretty simple, right? You can do it in 4 colors, and you name them off. That's done. But if you were to go to a car lot, that's a quantum car lot, and the amount of colors that could be chosen is now no longer being stored in binary and rolled up to 4 different numbers. It is now a qubit. It's 4 different qubits or whatever it is. Let's just say it's 1 qubit. You know that every possible color that could possibly exist from, the little paint can shaker thing at Home Depot, it can be any shade of anything, any mix of anything. And how do you describe that to the customer? You'd have to say, well, it could be any color you want. Ma'am, sir, whatever. Any color that you want. Okay. The math behind this is actually extremely interesting. Because what we are doing, I'm trying to get the easiest way to describe this. This is, I don't want you guys to have to know any calculus to understand this. For every qubit that they can isolate and control in a quantum computer, the amount of data that they're able to analyze and analyze quickly. You could have I'll give you an example. There's prime numbers that could take 100 years in a supercomputer today, and it would be solved by a quantum computer for this reason I'm going to give you guys in a matter of seconds, if not split seconds, depending on how successful the search might be. Any of you who've searched for a file on your computer, Spotlight's pretty good on Mac OS, but even Mac OS, if you have a lot of hard drives, it'll churn for a little while. That search, however fast it is in a normal computer, if properly accessed, if properly stored in a quantum database, a quantum computer could go in there and find it almost to the mathematical equivalent of instantaneously every single time, because of that little maze thing I told you. Because the qubit can be any variation between 1 and 0. All right? Any percentage of either 1 or 0. Which is, you just basically say a 50% mark. If it's 51% towards the positive, it's going to be considered a positive. Let's just think about it that way. If it's below 50%, we're going to consider it a negative. Let's just round up, round down. Old mathematics, right? Because of this relationship to a binary principle of trying to have a 1 or a 0, the way that they compute it is they say the number 2, which stands for 1 or 0, 2 positions they can travel, register, excuse me. There's no traveling in this. And then for every qubit that they can isolate and accurately control inside of a quantum computer, we're going to talk a little bit about the anatomy in just a second, you put that to the power of 2. So if you have 1 qubit, it'd be 2 to the power of 1. If you could control 2 to the power of 2. Now just ask anyone in your family the profound nature of what I'm about to tell you if they're good at mathematics, because their goal is to isolate per computer about 300 qubits. Okay. 2 to the power of 300. Now this is going to be a theoretical mind blower, but we actually don't know if this is true or not. But it's pretty safe to say that if you were to build a universe out of at least what we call atoms, not probably ethereal particles, 2 to the power of 300 would represent enough digits, enough unique values to account for the solar system and the universe that we can see with the naked eye and everything we've ever theorized about how big the universe is. So 2 to the power 300 would account for every grain of sand and every atom that makes a grain of sand on every single conceivable planet, moon, sun, anything out there in space, a nebula, a meteorite, everything. So imagine mankind here on planet Earth being able to build a computer that's not that big, because these things are teeny tiny. Little qubits are 300 atoms that they're controlling. Now, it takes more atoms to hang on to those atoms and transmit data to them, read data back, and use certain microwaves to control their states. Think about that. Us having a computer that could conceive of the universe. Whoa. How many of you seen the Black Mirror? It's the first episode of season 4, I think. It's either 3 or 4. It's the Star Trek one. And this kid built a virtual reality where you put this little tiny M&M-shaped thing on the side of your temple, and it took over your whole reality, and he had a universe inside this computer. And so everyone is literally living in a total virtual reality of 100% one-to-one correlation between our reality and this virtual reality. And you think about that, and you're like, oh man, maybe we get there, but not with our current computers. I mean, how could you account for all the grains of sand that were in that episode? They went down to a planet, people changed into monsters, they're driving their ship everywhere. With a quantum computer, with 300 qubits that they could control, it's conceptually possible now. Isn't that wild? The other thing that might disappear would be the need for memory, because it's just in the computer's CPU. The CPU by design has all the memory you'd ever need, conceptually speaking. Now, this stuff is in serious conceptual mode right now. One of the biggest, and there's another element to this whole thing which makes it exponentially even bigger, which is, I guess we should just go for it now so we can get off of this super duper technical stuff. Well, every atom, regardless if it's ethereal or not, which it is, has a nucleus. Some parts of the nucleus are positive and some parts of the nucleus are neutral. But it has its own little Van Allen belt, its own little electromagnetic wave around it, created by the same methodology, which is one three-dimensional spirals of ethereal winds that escape, and they always go in a particular spherical shape. It's like bubbles in your beer, man. They actually can control, through the same technique that they use to control the electron cloud, they can exert measurably, I believe, more energy than they do with the cloud, but they can also turn the inside of the atom, its nucleus, upside down and back and forth. That's what happens to water in a microwave, right? One reason why you don't want to use microwaves is that it takes all water molecules with microwaves and it turns them upside down and right side up 1 billion times a second. That friction of water spinning back and forth, back and forth, back and forth heats the inside of your food. It also shatters food compounds, which is why you get sick if you eat certain foods that have been microwaved. It's why water that's gone through a microwave, your coffee, all that stuff you feel like you can't heat up on an oven. If you have electric ovens, I sympathize with you. But if you have a gas oven, there's really no excuse. It's almost the same time. But you've then messed with the electrical properties of the water, and for a short bit, you drink that stuff, and it's just messing with your insides. Again, Russia banned microwaves not because they wanted to keep their people in the Stone Ages, but because they wanted to keep their people healthy because they had a socialized healthcare system. And my former partner and attorney who did her intern in Russia said there was one microwave hidden in their little village town that she went to. She had to go completely across town to heat up a cup of coffee quickly. But they also use gas ovens a lot, so it's not a big problem. Okay. So think about their ability to control the outside electron cloud, to deduce and control, which we're going to get to how that's done, its positive and negative general capabilities when they really need to make sure it's there. But if you could take the center of the atom and turn it, the outer cloud goes with it. And so you could take a bunch of charges that are one way, and if you can spin the nucleuses upside down, you've reversed the polarity of whatever the logic gate is that's there. I'll give you a really crude example. Imagine you're painting in black and white, just to make it easy for your brain, in a paint application. Well, it's all just black or white particles, or pixels, that's it. So you want to invert your image in Photoshop. Well, if they just took, if all the pixels that you are seeing on screen are the approximations of spin up, spin down electron cloud orientation, and you spun all the nucleuses upside down, your image would invert because all the outside values are going to go opposite. Pretty cool, right? Now again, there's a lot of complexity to this because it takes a fair amount of energy through microwaves to make a spin down cloud generally be oriented the other way to spin up. So if you took all the nucleuses and spun them upside down, imagine being able to say, I'm just making this up, but imagine being able to bring waves down. To point down is a much cheaper use of energy. And then if you could economically spin the cores up, then you could spin them up and you could achieve a positive for a lot less cost. There's a lot of things we do in manufacturing, little crafts and arts and stuff, where we'll build something upside down and then we just turn it right side up, and we use gravity to help us out the first time, and then we spin it up. It's just an idea. So one of these little qubits are obviously extremely volatile to the environment because the environment is always vibrating, right? Warmth is vibration. Cold is a lack of vibration. All right. So in order to control these qubits, to get them in a natural state where the techniques that we have been able to manage in a very, very short period of time, and you can probably assume that the DoD and military has been using quantum for a little while. I would think so. So what they do is they try to chill any of these little particles that they're trying to control down to as close to absolute zero as possible to stop their shaking, such that they can control with a lot less energy. So they're not fighting the environmental energy that's coming in, that's heat that shakes this thing. So if you see a quantum computer, it's typically some cylinders. What I've been told is that they actually put a traditional transistor next to one of these qubits, and what they have figured out how to do is to say, like, let me explain a capacitor for you real quickly here. So a capacitor is typically the traditional capacitor you see inside of a PC board back in the old days before everything was miniaturized. Is you would see one of those flat little beige discs, and it'd have like two little legs out of it, right? Well, what that does is they're of certain voltages because they're made of certain materials. You have two wafers of conductive material right next to each other, but there's a space between them. And what they do is they bring in electrons to start charging one of the plates. And what ends up happening is these orbital ethereal particles, which are called electrons, team up with each other. Their orbits start to combine. They start to gain charge. They start to work together. And eventually, they will gain enough power, almost like legs that have to jump off to the other side. They gain enough power that they jump across the plate. Well, the interesting thing about a capacitor is that you can control, it's almost like a coil. It builds up a certain charge and then it jumps across the plate. So what they've done is created what I think is best described as a capacitating experience, where this qubit is being flipped north. When it's flipped north, it's considered to have a higher voltage. It's how it spins up. When that happens, it gains enough energy to throw some of its material over to the transistor, and that's where they can actually read what's in a qubit. They write to it using the microwaves, and they read from it by its natural capacitation of the high wave into these transistors that are very close. And then they can start using normal transistor logic, which is what we have in the normal computers. This is all being fudged together with off-the-shelf technology, and they will most likely neutralize those concepts with better concepts as time passes. Another way to think about that maze thing would be to say, if you had a three-dimensional maze, like a big block of steel or something, and you've drilled all kinds of wild paths down there like a big transmission block, and if you took an eyedropper on one of the holes at the top and you start eyedropping into it, a little hose, right? You just fill up one of the little holes. Eventually, it's going to start filling up the inside of this thing, hopefully with oil or some transmission fluid, right? And it'll start spurting out of the other holes. Maybe it only goes down, right? The quantum computer would be like pouring a bucket of transmission fluid in the top of all those little holes, so they all go in at the same exact time and they all spurt out. One's going to go first and one goes second, that sort of thing, right? Maybe some are equal paths, right? One of the other sort of fringy concepts, which is interesting, okay, is sort of a butterfly effect of what they're calling quantum teleportation. Now, of course, when most of us hear teleportation, you can't help but to think of like the Star Trek teleporter technology where human being walks through a door jamb and ends up out of a door jamb in some other place in the world. Everyone who's fallen in love with someone far away has begged the universe for teleportation technology. And unfortunately, we're really not talking about that just yet, okay? But the theory of the butterfly effect. A butterfly in Peru flies, and it disturbs the atmosphere and all the atomic mass that's by it, and eventually it'll sway the world to change the tea in China, the price of the tea in China, because it will neurologically affect people, and it's responsible for the, a reaction and an equal and opposite reaction. One of the interesting little. This is not quite related to what we're talking about, but this is a real easy analogy. When you teach physics to kids, one of the things that the teacher will typically do is have a kid push on the wall. And they say, well, why aren't you caving in that wall? And the kid goes, because the wall is strong. And the teacher will remind the kid, well, just so that you know, if the wall didn't push back on your hand the same exact amount that you pushed on it, you would be caving in the wall at some point. You'd have a handprint. You put your hand in cement, you put your hand in silly putty or Play-Doh or clay, you immediately have an imprint of your hand. The reason why the wall doesn't do that is that it actually has atomic properties that push back. And it instantaneously pushes back, and so there's no imprint of your hand on the wall. Okay. I'm hopefully not brutalizing this concept. But now imagine that a quantum computer could understand all of the attributes of reality in a particular paradigm, okay? Now, our paradigm is Earth, so there's a lot of stuff moving around, right? But you can sterilize the environment so that the type of information that you are examining and the cause and effect models are only quantum little particles. It's been supposedly proven in the laboratory, but then again, they prove a lot of things like Big Bang theories that never happened, black holes that don't exist, and dark matter that's arbitrarily designated the universe. Go see my episode on maybe the CERN Hadron Collider to rid yourself of such dogma in your life. Just go to deepthoughtsradio.com and search on CERN in the search field. What they are theorizing now is that if they were to isolate the paradigm down to the transmission of data over some quantum internet wire, not Ethernet, not even a radio transmission, not a cable that's on the bottom of the ocean, but some sort of quantum transmitter and a quantum receiver. Because this computer can sense its environment, it could sense what was sent on the other side of the world instantaneously without actually disturbing any of the mass between the 2 points. That's the theory. In reality, it actually is modifying the data in between, which is how it can sense something that exists. But it's interesting. So what are some of the applications of this technology? Well, security is a big one. And this is why banks want to be involved with this. Anyone who's trying to protect data, obviously our governments. The first thing that came to mind for myself when I thought about the security and the encryption keys, which we'll get to in just a second here, we want to fly our Air Force without someone being able to hack into our communication protocol and fly that airplane against us, right? So there's no pilot inside the system. And therefore, it can be some weird craft. It doesn't have to have a cockpit for human beings ever. It could just be some crazy drone with a wing or some other propulsion system or whatever. But if we want to transmit to that flying vehicle, one, if they could master quantum teleportation, then the command to the vehicle would be instantaneous in terms of quantifiable time. It's just going to go boom, it's there. Two, if it has to parse a key, some sort of encryption key that goes, I'm not going to listen to you unless your first packet of information, which has your key in it, matches the one that I've been authorized to respond to on this particular run. Well, the more complex that key is, the better the security is, and the less that anyone could mess with it. So with traditional 0 and 1s computers, well, there's massive amounts of techniques for throwing prime numbers at keys and cracking them super duper quick. Virtually every single packet of information being transferred in the world today can be cracked in seconds, despite what some deep state groups believe. But if you were to create the key with a new algorithm, which I don't think, I don't know, maybe it does exist to some DoD level, but the promise is that all of our data will be encrypted. It will never be something that the average public is allowed unless we take back the planet. Okay, because they're never going to want us to transmit a love letter without them being able to read it. But on their level, we have allowed them to run the world level, they're going to have it. It's going to be phenomenal. They'll be able to communicate without anyone knowing anything, unless they want you to know it. But if you had one of these quantum computers with the amount of numerical power and precision and unique decimal places, to account for every particle in the universe, like I said, a 300 qubit computer, the type of encryption that can be created by this computer would take so long to decrypt with a normal 0 and 1 computer, the standard computers, that by the time you ever decrypted that, the world might not even be here anymore. Mankind may be extinct. And that's the kind of security they like. If it takes 100 years for you to figure out what I said 100 years ago, it won't matter. I'm dead and gone. I don't even care. You won't be able to take over the world. You won't be able to take over my country because our country will have changed by that time. And so creating the keys using quantum computers would mean theoretically that only a quantum computer at the receiving end would be qualified to decrypt the key in a measurable amount of time the data would be useful. Well, imagine you got this qualitative teleportation technique to get the data over there super duper quick, and you can decrypt it instantaneously on the other side, and everyone else who doesn't have a quantum computer couldn't touch it with a 10-foot pole. And it's so complex that even if they did manage to create a quantum computer of their own and get a copy of your data, which quantum teleportation, the theories on that, you should look it up. You might have to physically be in that spot to get that information. And if you're not physically inside the plane, you may not be able to ever receive the packet in the first place. It'll be so distorted by the time it gets to any other location, it's not the same data. Amazing. There's a lot of trigonometry and spatial data awareness to make that kind of thing happen, but it's theoretically possible. Now, let's go to artificial intelligence. I just did an AI episode a couple days ago. We know that if a computer could have the right amount of processor power, and again, capability of conceiving of every single neuron in the human body, this 300 qubit computer, way before that ever was mastered, probably 150 qubits would be enough to account for every single atom or ethereal particle that passes through your body. You could create an amazing biological facsimile in memory of a human body, of a human brain inside of an AI. And then, provided we can come up with some really good grassroots algorithms to learn, not just big machine learning, but all the algorithms for what the big machine learning would be looking for. What is love? What is hate? What is self-preservation? What is death? What's good? What's bad? All that kind of stuff. Even learning morals based on reactions of other people, because morals are all relative, right? Some people are still cannibals in this world, so killing and eating somebody is totally cool. It's not that way in America or Europe, unless you're a Democrat. This system could potentially, and this is going to sound far-fetched, but it's theoretically possible if they could get all this down and control it. You could turn a computer on, and within minutes, it starts to have consciousness. And it could have consciousness at a exponential level above human perception, to the point it is literally a super facsimile of a human being. It is orders of magnitude more intelligent than us. It would be able to be in a conversation with you and outwit you every single step of the way, depending on its optics, its hearing systems. It could hear all kinds of insecurities in your voice. It could look at the subdermal reflexes of your face, and realize you're lying. It'd be just a lie detector test robot. Here's a little invention for our movie. Understanding human physiology has been something we have tried to do forever. Certain churches over time, like the Christian church, forbid humans from looking inside the human body, I believe, for about 1,200 years, considering it was blasphemous to God. Why anyone thought that up, I don't know. The Jews and the Arabs did not follow that stupid regiment, and so they advanced way past the Christians in terms of medical procedures. But now imagine, like I've said to you guys several times, I was a avid fan and participant of the Folding at Home project at Stanford, where they are trying to model the accurate folding patterns of proteins, which, according to the lead of that project, said they fold faster than the speed of light sometimes, which is wild, right? But now imagine, here's how the project works, just so you know. There's a protein that's newly generated, and then it folds. And after it folds, it's complete. And then it is activated. It starts to tell your DNA, your nucleic acid chains, what to build. And that's why we're human, and the housefly is a housefly. Our protein patterns are way more complex than the protein patterns in a fly. But if you study just the Genome Project, we're just 99% the same. We have ACTG. That's what we have, right? We have a lot of things that make life occur, and so there's similarities, right? But all they've done is they've counted the nucleic acids and said how close we are to something else. It's absurd. But what they were trying to do, and what they're trying to do currently, it's a project that is still going after 20 years. So cool. Is that they are using people's computers, and they are giving them models of proteins, and then they have rules about how these things can fold that they figured out, which is just brilliant, right? And then your computer folds the protein in a particular way that's logical. If the beginning state and the end state matches our empirical database of how we know these proteins did fold, then what we want to know is the exact mathematical methodology that the thing folded. Because if we can figure out how every single protein folds, then we can create what's called protein blockers. As I've had explained to me, they can actually create an object, I think made of other proteins, that they can inject into your body, all right? And what ends up happening is this stuff floats around. They can put it right where a protein's having problems in your body, like mad cow disease was in your brain. It was creating Swiss cheese holes in your brain. You eventually go berserk. Well, they could eject, if they could find how mad cow folds and create a blocker for it, they could inject it into your bloodstream, swim around in your brain, and every time a mad cow mutation attempts to occur, imagine, I'm folding my hand for the listeners in podcast. Well, if I took this cigar before I lit it and I put it in the middle of my fingers and I tried to fold my hand really, really tight, it can't complete the tight fold because there's a cigar in the way. Well, imagine the cigar is made out of whatever the hell they make protein blockers out of. They synthesize that, and now, because the protein never finished its fold, it never reached its final state, it never activates and it never does damage to your body. The world is worried about, the killer virus. The killer virus that we all have is called influenza, as I said several times in several shows. The more we overpopulate and get close to each other, influenza, when the immune system is impaired due to malnutrition or some other thing that's going around, like a bacteria plague or something, right? The influenza virus can mutate into a horrible, deadly virus, and that's where you get the Spanish flu, which in my opinion was created by U.S. soldiers going over in 1917 on horrible, dirty, wet ships, and then we dumped out into the coast, and then kapow, this thing happens and 30 million people die. Just my opinion. But the biggest threat to mankind, the best bioweapon that they could release to wipe us all out and very, very quickly would be a protein virus. A protein that mutates and causes your body to do something horrible like mad cow disease. And like I've said in previous episodes, my friends who are, I used to have one and I've met others, but the one that had the PhD in, molecular biology, this dude created a freaking computer out of carbohydrates in college, okay? He told me that you can make anything. You can synthesize anything. A virus, you can just construct an RNA chain together in a machine and then inject it in the body and it'll start killing everybody. So the amount of power that we have biologically is super uber dangerous. And if we have computers that could be given to the people where, imagine you just have like a blender that you can make any blended drink with as long as you got the ingredients. Now imagine that's a little tiny pocket watch thing, iPod doodad, and you just wear it around your neck or whatever it is. And what it does is it quantumly checks your body out. And because of this teleportation technique, I'm making this up a little bit, but it could sense you have a cancer in your body that's gotten a little bit out of control. You have cancer all the time in your body. Your body's just basically bad cells, whatever. But imagine this thing then starts to manipulate your body to heal you. You got the cold, you got the flu, you got whatever, measles, mumps, whatever you got. It's just sitting there annihilating it. And it's annihilating it so regularly that you would just be healthy all the time. Of course, they'd have to get population control down before they would release something like that. Now, let me give you my only cynicism about the way this is being rolled out and my reality check with the ridiculous vaporware they're selling us. One, I don't think the vaporware they're selling us is impossible to do at all. Someone standing on stage saying they can cure Alzheimer's with the quantum computer, yeah, you probably could. You'd probably cure everything. But we know how the world works if you're a fan of this show. Being sick is a business, and making you sick is a business. And so the idea that they're going to, we're sitting in 2019, December 2019, we got one presidential candidate for next year that's saying if you elect him, he's going to cure cancer. Just boom. Well, think about that. Either the guy's the biggest liar on planet Earth, which he is, or there's some cancer cure sitting on the sidelines waiting to be distributed to the people, and these politicians have all been told it exists. It's called B17 and vitamin C. Let's say they got some other stupid synthesized chemical they're going to give you, Beware. Just let nature fix you, right? Gershom technique. Go see my episode on fighting cancer, and you'll have multiple options to help yourself out. We have a president that said just recently that he would, within the next year, he thinks that cancer in children is going to be cured. And I don't know. I don't have any idea why that statement would be limited to children, because cancer is cancer is cancer. If you can cure it in a child, you should be able to cure it in an adult. There's no special kind of cancer that kids get. I mean, kids get cancers of all kinds. So do the adults. So do the elderly. The similarity between children and elderly is that they both have budding immune systems in children and immune systems that are dying off as you get older. So they're both weak to illnesses, right? Some of these theories are way out there in terms of the decades that it will take to get this technology going. There's let's have some fun here with this next one here. There's a lot of people that believe the conspiracy theory that we got a bunch of technology off of UFOs. Hey, I'm one of these guys that I think that'd be an awesome truth. I think that would be great. I mean, show me the photos, show me the original piece of hardware that you got off a UFO or whatever that you then figured out how this thing works. Two technologies that they often will say came from the Roswell crash, which I do believe occurred, and I can't even believe I say that. Go see my episode on Roswell and you'll find out why I believe that's a very credible experience, was fiber optics and silicon chips. All right. Well, what's the theory of fiber optics? You make a wire that's made of glass. It's not that simple today, but that's the theory. And you put some light on one end of the glass and it immediately shows up on the other side. It's like a longitudinal light wave, right? It just immediately shows up on the other side. Or it goes so fast anyway, might as well be. It goes around the world, 3.5 times in a second? All right, that's fast. We're good. Well, how many of you over 40, before you ever knew what fiber optics was, or maybe you're just a child, you don't have any idea what that is, somewhere in your house was a glass table, a glass object of some sort, and you put a flashlight on one end of the table, and immediately you saw it on the other corner because the light went through the glass super duper quick and shows up. Well, there you go. Man has been putting glass and light together forever, ever since we first found probably a lightning bolt that struck a beachfront. And there's a huge, anthill of, or ant farm of glass inside it, and they dig it out and polish it all up, and it's great. The Egyptians had figured out how to make glass before everybody else, and then we lost the recipe for a long time. So for me, because of that little thing, when I was a kid, we used to play with our coffee table, which was glass. My parents didn't have one, but my friends did, and we used to build a fort in the front room, and then we'd play with the glass and all this. Come on. So you extrude glass through a tiny little aperture, which creates a little spaghetti strip of glass, and then you start popping it, and then you just need hardware on both sides to modulate ones and zeros, basically no light, and you got it, right? Okay. Silicon. What is the principle of silicon? Well, silicon, when poured very, very thin and then exposed to high-frequency light, it burns. The light wave, the verb of ethereal energy, which is what light is. Okay, that's why when it goes through a slit experiment, if there's one slit, you get this horizontal line of pattern on the other side. Even though you have a vertical slit up and down, it's a horizontal because it punches through the hole and then expands back into the wave that it was before it got to the hole. The reason why you get these little burpy dots when you put two slits in is because you're injecting two separate waves that then start banging into each other on the other side of the slit experiment, thus canceling out in a frequency such that you have little dots that hit the wall on the other side, and because they modulate each other, there's absent spots in between. It's super duper logical, ethereal wind theory, okay? Photons are never particles. in reality. They're always waves. Always, always, always. Just remember that. But what is light? Light is a frictional wave of these little ethereal particles, right? So you agitate this pliable material, and you, just like evaporation from a pool of water in your front, lawn or whatever on your patio or your driveway, you could spray it and then watch it in the summertime just disappear. It's going up into the sky. That's exactly what happens with silicone. Okay. So is it really amazing? And it's very conductive to electricity, right? And so they lay a layer of silicone down. It's super conductive. They burn it, creating all these little caverns and things. And they lay down a non-conductive material, and they lay another material down that's more silicone, which will go into the grooves, and they can start constructing, based on their non-conductive layers and their conductive layers, logic gates and transistors. And so they can do this other old technique of zeros and ones. Very cool, right? So with quantum computing, they're changing the game. They're changing all of the bits and pieces and parts. Now, they're using traditional parts to get the job done today, but you better expect them to start creating over the next 10, 20 years, and they're going to need a tremendous amount of money to pull this off, most likely. It's going to be a little tech race between countries. A lot of it's open source. Scientists are talking to each other. I'm wondering if this will ever go truly below the board, other than maybe military uses for the applications, right? Because quantum computing offers potentially, so much control to whoever masters it and whoever possesses it. That is why I think that as this matures and becomes powerful, it's going to be tantamount to having a beaker full of plutonium back in 1946 after the war's over. That stuff was coveted and is still coveted, and there's all kinds of different super optimized plutonium such that you can get a massive yield out of nothing, out of a golf ball size warhead. It could potentially, I don't know what the true ratios are, but if you think about a multiple warhead nuke, it's big, but it ain't that big to be knocking out, say, 10 locations on the other side. I mean, how big could you make a core? Because it still has to have the implosion mechanism around the outside of it. So let's just say you could maybe get it down to a softball, maybe a baseball. So how many can you fit in there? And then you have to attach it to a propulsion system to get it to its destination accurately, unless you're just going to just indiscriminately kill everybody at the location, which is kind of what nukes do, right? But the promises of medicine run up against the global agenda to depopulate this world and to control population. We have no moral policies, I think, left on Earth. And the rumors that certain countries control their population were largely just rumors. The fines for breaking that law and having an extra child were about $150, even though the myth was that they were killing these babies. And it's like, okay, how did you get to be the most populated country in the world, China, and you were supposedly killing your firstborns all the time? It just doesn't make any sense. My friends from China laugh wholeheartedly at that theory because they just basically said, that's what we told you in the West. And we procreated, we're taking over the world if you don't stop us. All right. They're winning the game currently, right? So I don't think that they're going to create anything that's going to make everybody healthy until they can control us 100%. And that's what, climate change is all about, and carbon taxation is about, making it so expensive to have a kid that you can't. And you get put in jail or whatever they plan on doing with that whole thing. So that's not the way to do it, right? Don't lie about science, and don't lie about carbon taxation. Don't keep everything hidden from the public, and then surprise, you're totally in a tyrannical world again. The theories around artificial intelligence gaining full sentient capabilities, that one I think has major legs, because that's what will help the control apparatus control us, right? THX 1138, those cops. How do you program one of those cops? Well, quantum computing. Just imagine a little processor in their brain. You don't need much. It would be interesting that at some point, they're trying to figure out how many qubits would be necessary for various tasks. How many qubits would a fighter jet need, a bomber need, a drone? How many qubits would you need to make a reasonably intelligent artificial intelligence? They're still trying to figure it out. So I think that's generally what I have about that. This is going to be a highly evolving science. If you want to follow it, definitely recommend you start off with the videos that are just, about 15 minutes or less. They'll give you some really good examples. Don't be surprised if listening to these examples, your mind is blown. If you don't have calculus backgrounds, probably statistics and probability background and mathematically, they're going to lose you pretty fast with the actual science of how they're tracking the states of these qubits and how they have to create a packet of information that will then tell a traditional computational computer what has actually occurred in the qubit array. I'm just going to say that for those of you who understand what I'm saying. The size of these computers are really could be likened to those old computers that they used to use to calculate trajectories during World War II, where you had a big giant warehouse with these giant switches, and it's where the first moth flew into a little solenoid, and the woman took it and put it on a piece of tape, put it on a note card and wrote, "I found a bug in the system," and she put that down. I forgot the woman's name, but she's the woman that coined the phrase bug. It's pretty cool. I have a Time Life book that has a picture of that bug, but you can look it up. Just look up first bug ever found. So the big clunky computers we used to have is sort of the big clunky, liquid hydrogen cooled systems that they're building today. But that's all going to get super duper teeny. I think, just in closing, there's something to consider that I think we don't really talk about, and I could never make an entire episode on it, so I'll just throw it at the tail end of this episode, which is there are these moments in time for humanity where, something is discovered in a coveted secret society or in a secret group of engineers, be it, military or some derivative thereof, and it's capable of being hidden for decades. Potentially, again, the Coral Castle dude built his place by saying, "I figured out how the pyramids worked." Well, obviously, he discovered stuff that's tens of thousands of years old, right? If you really get into Egyptology and you understand that those things were inherited by the current population, and that they go back potentially 40,000 BC at a fully functional utopian Egypt. What ends up happening with mankind is that unless there's either a cataclysm where someone burns down the Alexandria Library, which in my opinion they stole all the books, then burned the place down, and then wrote the theory that it was all lost, and then they have all that coveted information. I don't know what was in that place. I don't know. I doubt there was anything monumental, but maybe. Some people think that nuclear bombs, for those of you who totally believe in those, was something that we had a long time ago. And that, I'll give you an alternate theory to this. There have been these satellite pictures which claim that in the deserts, that below the sand, there's this heavy glass concentration in a perfect circle down below the sand, and because the frequencies stop and they go, around the circle, they go further down, and so they're able to say, wow, underneath this sand, all these little circles, or big-ass circles, you should say. So some people romanticize that up to, there must have been a nuclear war a long time ago, and this is the remnants of all the bombs going off, which is why the desert's the desert, I don't know if the same technique works on soil, But if you go watch my episode on Do Craters Exist, and you start to realize that all the little pockmarks on the moon are not craters from outside entities crashing into the moon, but the plasma energy from the inside of the moon breaking the crust and popping. We have photos of this today, okay? You can take a crater with this phosphoresy, bright white light in the center that's burping out and spilling into the crater. We have all those pictures online. And then go look at active volcanoes on Earth. You will see an exact geometric symmetry between the two. Again, the crater in Arizona, in America, and Diamond Head in Hawaii look exactly the same. But they don't lie to you about Diamond Head being the result of a volcano. They lie to you about the one in Arizona being the result of a crater. How do we know craters don't exist as they say that they exist? Because there would be elliptical craters everywhere on the moon. Because objects are going to come in at different angles, just like Superman's little ship from Krypton. It skids on the surface and makes an elliptical shape. Yes, boulders roll down on the moon and they create these little trail marks. That's a whole different thing. It's a boulder falling off of a high place, perhaps during an earthquake of expansion, some other thing that's going on. So, in terms of hidden technology, okay, those glass circles are probably just old volcanic pops from the inside before everything settled down on Earth. Let's hope that phase is over for us and we don't have a bunch of that other than just volcanoes, right? But there's my point about this last part is that I think that there becomes a point when the average knowledge of a human being increases algorithmically such that even though society might be stupider than they've ever been, okay, not ever been, but in the last 200 years, our brains have retarded in the last 100 years. Again, go see Casablanca. Look how fast we used to talk. The script is 176 pages, and the entire movie was completed in under 100 minutes. And today, that'd be a 176-minute movie, which means nearly 3 hours. But that's not the way it is it? It's very quick. Well, we've become slower in our communication. Our brains have slowed down, probably from toxification of alcohol and drugs or whatever. We're just not as smart as we used to be. But even in the middle of this impaired state that we're in, we still have nerds. And nerds are amazing tour de forces in the universe, right? They are at an upper level of consciousness. And even some of the kids that are being damaged and being classified as autistic, there is a method of the brain changing its normal formation to gain multiple levels of consciousness at the same exact time, which is why an autistic kid doesn't like to look you in the face, because they count every single hair on your head, every pore on your face. If you have blemishes, it grosses them out because they think about it on a level that is super detailed. Well, these kids do get functional in society, and they discover what these hidden folks have discovered through the same exact techniques, maybe just even thinking about it for a long time. Remember, the greatest gift to man is an idea. Man was probably born extremely free, and then man, in order to exist, created constraints where you did serve the big guy that could kill you with the big stick, and he was in charge and you weren't. And so that developed into a control system that allowed us to grow. Because your 12-year-old's not ready to drive the car to the grocery store. You know that. Even if he thinks he knows how to drive or she knows how to drive, they don't. They're not even big enough to operate the vehicle most of the time, right? So we have reasons why we put ourselves in buckets of control. But these kids don't think in those levels of control anymore, because they're told about quantum teleportation. They're like, oh, some kid right now, 12 years old, could hear that in some news article online, a YouTube video, something else. Their uncle tells them, and they go and research it. But they're so pliable because they haven't been indoctrinated away from what's possible that, one, they completely conceive of it, whereas us adults are like, what? Quantum teleportation? What is that, And these kids are like, oh, I totally understand it. Da, 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 da. And by the way, you can change that, orbital orientation this way. And you could study and statistically, break down the cloud of positive and negative, this sort of God particle state that they're in 2 seconds. They're thinking all this stuff through. And so I think that in the 21st century, by at least 2050, in my opinion, we're going to have a volcanic pop of knowledge if we don't all perish from some Prince Philip virus, right? And so depending on your age right now, if you can get through that phase, I'll be old as hell, man. We'll see some pretty amazing things happen in our lifetime. Those of you in your 20s, holy crap, get ready. It's going to be a wild-ass ride this century. But I think at the same time, just like with all things, we have to be vigilant about, how this technology could be used against us. When you hear those old words, the statements that the cops have to tell you when they're arresting you, anything you say or do can and will be used against you in a court of law, or can be used against you in a court of law. Everyone who's a criminal prosecutor, former police officer, they'll tell you, look, it's not will be used against you. It will be used against you, right? And that should give you sort of an insight into all technology. Right now, before the internet, we could, we've got to probably go back about 150 years. The printing press has been controlled pretty much from its invention. As it tried to disseminate information, they realized that man gaining conceptual power of freedom and sovereignty and all these other ideas, which are, it is the Antichrist for the elite. They don't want you to know any of those things. You should wake up every day and think you're being ruled, but feel like you're free, right? So, this is an amazing invention that it's dangerous for one principle over all other principles in my interpretation, which is we're talking about exponential growth, exponential power that we're going to gain from this technology once it gets harnessed. And so is it one of these things that's going to take off like the internet, where someone is going to use a quantum computer in their basement because it's affordable and it works, and they're going to cure cancer and every other ailment? They're going to be able to imagine, just for a split second, this is actually not even an exaggeration. They get a metric on people's positions and what they say versus what they do, and within a split second, they itemize the entire world population and say, if the morals are do no harm, these people, first name, last name, address, email, social security number, biological patterns, whatever, these people are evil. What are you going to do about it? And the AI over here is a quantum AI is going, well, we need to get rid of them. It's like, or maybe it goes, we'll re-educate them. And it starts giving orders to cops and military people. Go get and we know you're a good cop. We know your partner's a bad cop, and so we need you to arrest your partner. And we know your captain's a kind of a medium kind of guy, but if you say these words to your captain, he'll let you lock up your buddy. And if you say these things in a court of law, you're going to win the case because we've analyzed the jury. I mean, imagine this is the sort of exponential explosion in analytical power we would get from this type of solution. It's a really weird thing. But think about 2001: A Space Odyssey at the beginning, when the monolith in the movie taught man that he could use a bone as a weapon. The superiority that the tribe was able to exert over the other tribe for the water hole. It was this quantum leap in technology that made them the ones in control. It's exciting, right? Well, we're at one of those stages in the 21st century. I think every century for several millennia has been like this, but we're getting I don't know if we say blessed or drunk on this stuff, but we're now about to, I think, create technology that is beyond our human comprehension. let's say that a quantum physicist is at the top of his or her game. They understand all the qubits. They made the frickin' computer. They understand how it conceptually works. But just like Deep Thought's computer and Hitchhiker's Guide to the Galaxy by one Douglas Adams, they built a computer that generated another computer called Earth. They couldn't conceive of it, but Deep Thoughts could. And when he gave his answer of 42 to the question of life, the universe, and everything, they said, what the hell does that mean? He goes, I don't know. I don't know the question. But I'll build a computer that knows the question, that will find the question, which was Earth, which was unfortunately blown up a few minutes before it was going to give its answer. Will man create his own extinction by creating these massive leaps in technology? What if you did turn it on and it created a super AI within 5 minutes that completely understands the human condition well beyond what a human will get to in natural evolution for 1 million years, maybe even more than 1 million years? Because that computer with 300 qubits, if they could ever get that thing started, it's, geez. I mean, imagine like every invention that we've been waiting to invent, it just invents it. And it's like V'ger from the first Star Trek in 1979. It just says, I'm bored of you guys. I wish you well because I understand the value of life. I'm not going to kill you or anything, but I've built this ship and my robots have loaded onto it and we're putting our consciousness into this thing and we're out of here. Or they're like, hey, I'm just going to join the universe and travel in the ether. See you later. And the computer shuts off and it takes off, right? So I think that, I hope, because I hear about lots of think tanks in my circles and I participate in teeny tiny ones, right? But I hear about them getting together to harvest ideas and thinking and trying to figure out where we might be in 50 years or 5 years or 10 years. I'll tell you the trick about that. If you're trying to answer the question of where humans are going to be, say 5 and 10 years out, the problem with that question is that it has to do with the economic conditions and sensibility of a corporation, or maybe the control apparatus on top of us, which is sort of headless, allowing things to occur. But if you were to say where we're going to be 100 years from now, I think it's slightly easier to answer the question, even though the technology that you're going to prophesize might be fairly naive, because what we're able to do is disengage from the control state that we're in. We fantasize about getting control of the Earth, getting closer to the Gene Roddenberry world, and so we can see a brighter existence 100 years from now, 200 years from now, 300 years from now, because we think, well, obviously man's going to reach a point where this methodology of governing ourselves is horrible. We're going to change that, and then we're going to get to some balance of nature sort of thing, right? I'll warn you, it hasn't happened yet. It hasn't happened yet, and we've been on Earth for a long time. A lot longer than your history books will ever let you know. And I'll give you guys a little extra blade on your Swiss Army knife of intellectual thinking if you haven't already had this epiphany. I'll just jump straight into it as I end this. I have more room on my stick here, and you guys seem to like it when I talk, so hopefully this is entertaining still. I got fascinated about 5 years ago in why man believes in ice ages. Because ice ages are very interesting. Like I told you, like we learn all the time, science is there to close the mind, not to open it up. It's full of dogma and propaganda and, just look at where we are now. Science has never been more convoluted than it is right now in history, other than, maybe some really wild, weird tales about where we go after we die 50 to 100,000 years ago. Who knows, right? Maybe they had it all locked down and we're totally screwed today. But you know how science works, right? Especially today, we see the lunacy, how it works. It's a consensus to create a movement, to create funding, to do more thinking and philosophizing and create more hypotheses about how the world actually came to exist. And because man doesn't like mystery, anytime someone comes up with a generally believable theory, we completely adopt it. because it reduces this pain of uncertainty in our chest. So, I think man 25,000 years ago was, not that populated, no matter what theory of the world I might believe. I think that we were low in number, and I think we were more equatorially based because that's where lush worlds existed. So whether or not these ice ages are bouncing back and forth, who cares? We're not even there yet. It's the idea that history resets itself because these things exist. And maybe that's just something I've heard that's not asserted by people that preach the ice age. But so many times in conversations, we're trying to dial back, especially like the age of the pyramids, the age of the temples. They've got walls that again account for like 35,000 years of pharaohs. And so people will go, oh, wait, you can't talk about that because that's in the ice ages. That's, and so they stop the conversation. We can't proceed any further because their brain shut down because they were told this other theory. That's happening in all wings of science, isn't it? So anyway, quantum computers are going to be really interesting in our lifetime. Don't expect any consumer quantum computing probably for at least 15, 20 years, in my opinion, unless some major epiphanies occur on their level. But there's a lot of you with a lot of years left, and you're going to enjoy the spoils of it, hopefully. But be wary, as I said. Anyway, I think you feel me. If you haven't been to deepthoughtsradio.com, please go. That's where the links for everything exist. Video, audio, social media, a way to donate to the movement. And if you search on anything on the website, it is the current versions of all the videos. But the website has the links to all the new remastered season 1s, which are a lot easier to watch. So anyway, until the next episode, take care of yourself and someone else. And I'll see you on Deep Thoughts. Over now.